Devices, as well as software components. Everything you need to know for information technology. Computer fundamentals. 1. General-purpose computer system. A general-purpose computer system is a device capable of performing a wide range of tasks and running various software applications. It consists of hardware components, such as the central processing unit, CPU, memory, storage devices, and input/output devices, as well as software components, including the operating system and application programs. 2. Functions of major hardware components. Central Processing Unit, CPU. The CPU is the brain of the computer responsible for executing instructions, performing calculations, and controlling the overall operation of the system. It consists of the control unit and the arithmetic logic unit, ALU. Main memory, also known as primary or immediate access storage. Main memory stores data and instructions that are currently being executed by the CPU. It provides fast access to the data and is volatile, meaning it loses its contents when the computer is powered off. Secondary storage. Secondary storage devices, such as hard disk drives, solid-state drives, and optical disks, provide long-term storage for data and programs. Unlike main memory, secondary storage is non-volatile and retains data even when the power is off. Input/output devices. These devices allow users to interact with the computer system. Input devices, like keyboards, mice, and scanners, enable users to input data into the computer. Output devices, such as monitors, printers, and speakers, display or produce the results of computer processing. 3. Functions and uses of primary storage devices. Primary storage devices, also known as main memory or RAM, random access memory, serve as temporary storage for data and instructions that are actively being used by the CPU. They provide fast access to data, allowing for quick retrieval and execution of instructions. Primary storage is crucial for the efficient functioning of a computer system, as it directly affects the system's performance. The main uses of primary storage include storing the operating system, running software applications, and temporarily storing data during processing. 4. Manipulating units of storage. Units of storage are used to measure the capacity of storage devices. The common units of storage include bit, the smallest unit of storage, representing a binary digit, 0 or 1. Byte, a group of 8 bits, which can represent a single character or a small amount of data. Kilobyte, KB, approximately 1000 bytes. Megabyte, MB, approximately 1 million bytes or 1000 kilobytes. Gigabyte, GB, approximately 1 billion bytes or 1000 megabytes. Terabyte, TB, approximately 1 trillion bytes or 1000 gigabytes. Word, a unit of storage that corresponds to the CPU's natural data size. The size of a word varies depending on the computer architecture. 5. Types of secondary storage media. Magnetic tape, a sequential access storage medium that uses a magnetizable coating on a plastic tape. It offers high capacity but slower access times. Floppy disk, a portable storage medium that uses a flexible magnetic disk enclosed in a protective shell. It has low capacity and slow access times. Hard disk, a fixed or moving head storage device that uses magnetic platters to store data. It provides large capacity and fast access times. Optical disks, CD, DVD storage media that use optical technology to read and write data. They offer varying capacities and are often used for distributing software, multimedia content, and data backup. Flash drive, a small, portable storage device that uses flash memory to store data. It provides high capacity, fast access times, and portability. Flash memory cards, small, removable storage devices commonly used in digital cameras, smartphones, and other portable devices. They use flash memory technology and offer varying capacities. 6. Terms associated with storage devices. Read/write head, the component of a storage device that reads data from and writes data to the storage medium. Sectors, divisions on a storage medium used to organize data. Tracks, concentric circles on a storage medium where data is stored. Buffers, temporary storage areas used to hold data during the transfer between different devices or components. Cylinders, a group of tracks on a storage device that are located at the same position on different platters. Access time, the time it takes for the storage device to locate and retrieve data. Sequential access, accessing data in a linear, sequential manner. Direct access, accessing data directly without having to go through preceding data. Device interfaces, standards and protocols that define the connection and communication between storage devices and the computer system, such as CSEC, IDE, and SATA. 7. Uses of various input devices and media. Optical mark reader, OMR, used to detect marks made on specially designed forms, such as multiple-choice answer sheets. Character readers, OCR, MICR OCR, optical character recognition, is used to scan and convert printed or handwritten text into digital format, while MICR, magnetic ink character recognition, is used to read characters printed in magnetic ink, often used in bank checks. Mouse, a pointing device used to control the cursor on the screen and interact with graphical user interfaces. Joystick, used primarily for gaming and controlling movements in specific applications. Barcode reader, used to scan and interpret barcodes, commonly found on products for inventory management and retail operations. Document scanner, used to convert physical documents into digital format for storage and manipulation. Keyboard, used for inputting text and commands into the computer system. Digital camera, used to capture and store digital images. Biometric systems, use unique physiological or behavioral characteristics, example, fingerprints, iris patterns, for authentication and access control. Sensors, input devices that detect and measure physical phenomena, such as temperature, light, motion, etc. Remote control, used to wirelessly operate devices such as TVs, DVD players, and other electronic appliances. Sound capture, devices like microphones used to record and capture audio. Pointing devices, input devices used to move the cursor or pointer on the screen, such as a mouse, trackball, or touchpad. Webcam, a camera connected to a computer or network used for video conferencing, live streaming, or capturing video footage. 8. Types and functions of output devices. Visual Display Unit, VDU, also known as a monitor or screen, it displays visual output to the user. It comes in various resolutions, types, such as CRT or LCD, and sizes. Printers, printers produce hard copies of documents or images. There are two main types. Impact printers, use a mechanism to physically strike ink ribbons against the paper, such as dot matrix printers. Non-impact printers, use methods like spraying ink, inkjet printers, or using laser technology, laser printers, to create the printed output. Other types include character printers, line printers, and page printers. Plotters, used to produce large-scale, high-quality graphics and drawings. Audio output devices, devices such as speakers, headphones, or earphones provide sound output to the user. Microfilm, a method of storing information on microfilm reels for archival purposes. Terms. Hard copy, physical output on paper or other tangible media. Soft copy, electronic output displayed on a screen or stored in electronic format. Human readable, output that can be easily understood and interpreted by humans. Machine readable, output designed for interpretation by machines or other computer systems. 9. Data storage and manipulation within the computer. Data is stored and manipulated in various components of the computer system. In primary storage, RAM, data is temporarily held for immediate processing by the CPU. In secondary storage, hard drives, solid-state drives, optical disks, etc., data is stored for long-term use and can be accessed and manipulated as needed. 10. Interpreting hardware specifications of a computer system. Hardware specifications refer to the technical details and capabilities of the computer's physical components. These specifications include the CPU type and speed, memory capacity, type, word size, and speed, as well as the hard drive capacity and speed. Other specifications may include the types of interfaces, example, firewire, USB, expansion slots, and ports available on the computer. 11. Distinguishing between systems application programs. Systems application programs are software applications that provide the underlying functionality and support for the computer system. They include operating systems, which manage the computer's resources and provide a user interface, as well as translators, compilers, assemblers, that convert programming code into machine-readable instructions. Utilities are additional software programs that perform specific tasks such as file management, memory management, security, and device management. 12. Functions of an operating system. An operating system, OS, is a software program that manages computer hardware and software resources and provides services to applications. Its functions include process management, scheduling and managing the execution of processes or tasks. Memory management, allocating and managing the computer's memory resources. File management, organizing and controlling access to files and directories. Input-output management, managing input and output devices and data transfer between them. User interface, providing a means for users to interact with the computer system. Device management, controlling and managing hardware devices connected to the computer. Security, enforcing access control, protecting data, and ensuring system integrity. 13. Distinguishing among multitasking, multiprocessing, and multiprogramming. Multitasking, the ability of an operating system to run multiple tasks or processes concurrently, allowing users to switch between them and perform tasks simultaneously. Multiprocessing, the use of multiple processors or CPU cores to execute tasks or processes simultaneously, increasing overall computing power and performance. Multiprogramming, an operating system technique that allows multiple programs to be loaded into memory simultaneously, taking turns executing their instructions, which enhances CPU utilization and system efficiency. 14. Types of processing modes. Batch processing, execution of a series of programs or tasks without manual intervention, where each program is executed sequentially. Real-time processing, immediate processing and response to input or events, with strict time constraints for completing tasks. Online processing, processing that occurs while the user is interacting with the system, providing immediate feedback and results. Time sharing, sharing of computer resources among multiple users or processes, where each user or process is allocated a small time slice to execute their tasks. 15. Types of user interface. Command-driven interface, users interact with the computer system by entering commands via a command line interface, CLI, or a text-based interface. Graphical user interface, GUI. Users interact with the system using visual elements such as menus, buttons, icons, and windows. GUIs can be further categorized into menu-driven interfaces, pull-down and pop-up menus, and icon-based interfaces. Hardware interface, user interfaces that involve physical interaction with hardware components, such as touch screens, sensors, or braille keyboards. Non-visual interface, user interfaces designed for users with visual impairments, utilizing audio or tactile feedback. Problem solving and program design. 1. Outline the steps in problem solving. Define and understand the problem. Clearly define the problem and gather all relevant information. Analyze the problem. Break down the problem into its significant parts and identify the relationships between them. Generate potential solutions. Brainstorm and come up with possible solutions or approaches to solve the problem. Evaluate and select the best solution. Assess the pros and cons of each solution and choose the most efficient and effective one. Develop an algorithm. Create a step-by-step plan or algorithm to solve the problem. Implement the algorithm. Translate the algorithm into a programming language and write the code. Test and validate the solution. Execute the program with different test cases and verify if it produces the expected results. Debug and refine the solution. Identify and fix any errors or issues in the code. Document the solution. Provide documentation and comments to make the code understandable for others. 2. Decompose a simple problem into its significant parts. Break down a complex problem into smaller, more manageable subproblems or tasks. Identify the key components and relationships between them. Analyze the dependencies and interactions between the parts, and determine how they contribute to solving the overall problem. 3. Distinguish between variables and constants. Variables. Variables are areas of storage that hold values that can change during the execution of a program. They are used to store data that can be modified or updated. Constants. Constants are values that remain the same throughout the execution of a program. They are used to store fixed or unchanging data. 4. Use appropriate data types. Choose the appropriate data types to represent different kinds of data in a program. Common data types include integers, used to store whole numbers, example, 5, -10, 0. Floating point, real, used to store decimal numbers with fractional parts, example, 3.14, -0.5. Characters, used to store individual characters or symbols, example, $7. Literals, directly represent specific values in code, example, hello, true, false. 5. Explain the concept of algorithms. An algorithm is a step-by-step procedure or set of instructions for solving a problem or accomplishing a specific task. It defines a clear sequence of actions to be performed, including input, processing, and output. Algorithms should be finite, have a definite end, precise, unambiguous, and provide a flow of control from one process to another until the problem is solved. 6. Identify ways of representing algorithms. Algorithms can be represented using pseudocode, a high-level, informal description of the algorithm using a combination of natural language and programming language-like constructs. Flowcharts, diagrammatic representations that use different symbols to represent input, output, processes, decisions, and the flow of control between them. 7. Develop algorithms to solve simple problems. Apply the problem-solving steps to create a detailed algorithm for solving a specific problem. This involves defining the problem, analyzing its components, generating potential solutions, evaluating and selecting the best solution, and representing the algorithm using pseudocode or flowcharts. 8. Test algorithms for correctness. Execute the algorithm using different test cases and verify if it produces the expected results. Ensure that the algorithm handles various scenarios and edge cases correctly. 9. Use the top-down design approach to problem solving. Top-down design is an approach that involves breaking down a problem into smaller subproblems or tasks and solving them individually. This allows for easier problem solving by tackling one component at a time and then integrating them into a complete solution. The process involves breaking down the problem into smaller modules, designing algorithms for each module, and gradually refining the solution. Program implementation. 1. Distinguishing between low-level and high-level programming languages. Low-level programming languages, such as machine language or assembly language, are closer to the hardware and provide direct control over the computer's hardware resources. They have a one-to-one correspondence with machine instructions and are typically difficult to read and write. High-level programming languages, such as Pascal, C, or Python, are designed to be more user-friendly and abstract away the complexities of the underlying hardware. They use natural language-like syntax and provide higher-level abstractions and built-in functionality, making it easier for programmers to develop software. 2. Distinguishing among the different generations of programming languages. First-generation languages, these are machine languages specific to particular computer architectures. They consist of binary code and are challenging to read and write directly. Second-generation languages, assembly languages fall into this category. They use mnemonic codes to represent machine instructions, making programming slightly easier than using machine language. Third-generation languages, these are high-level languages like Fortran, COBOL, Pascal, C, etc. They introduced more abstraction and provided higher-level constructs, making programming more efficient and portable across different hardware platforms. Fourth-generation languages, these languages are focused on database querying and manipulation, providing powerful tools for database management systems. Fifth-generation languages, these languages are designed for artificial intelligence and logic programming, emphasizing symbolic and declarative programming. 3. Sequence of steps associated with implementing a program. 1. Define the problem and requirements. 2. Design a solution or algorithm. 3. Write the program's source code using the chosen programming language. 4. Compile the source code into machine-readable instructions or an intermediate representation. 5. Link the compiled code with any necessary libraries or dependencies. 6. Execute the program either through an interpreter or by running the compiled executable. 7. Test the program using various inputs and evaluate its behavior. 8. Debug and fix any errors or issues in the program. 9. Maintain and update the program as needed. 4. Commonly used terms and concepts in programming. Variables, named storage locations used to hold values that can be modified during program execution. Constants, fixed values that cannot be altered during program execution. Control structures, constructs used to control the flow of program execution, such as conditionals, if-else statements, and loops, for, while, repeat. Functions/methods, named blocks of reusable code that perform specific tasks. Data types, categories that define the nature of data, such as integers, floating point numbers, characters, strings, and booleans. Operators, symbols or keywords used to perform operations on data, such as arithmetic, logical, and comparison operations. Arrays, Data structures used to store collections of homogeneous elements in contiguous memory locations. Algorithms, step-by-step procedures or instructions for solving a specific problem. Debugging, the process of identifying and fixing errors or defects in a program. Syntax, the rules and structure governing the valid formation of program statements in a programming language. 5. Elementary data types. Integers, used to represent whole numbers, example, -10, 0, 42. Real numbers, used to represent numbers with fractional parts, example, 3.14, -2.5. Characters, used to represent individual characters, example, $. Booleans, used to represent logical values, typically true or false. 6. Declaring variables and constants. Variables are declared by specifying the data type and a name for the variable. Example, int age, float temperature. Constants are declared using the const keyword and assigned a fixed value that cannot be changed during program execution, example, constant max_value equals 100. 7. Manipulating data. Reading from and writing to variables involves assigning values using the assignment operator, equals, and retrieving values using variable names. Data manipulation can include performing arithmetic operations, example, addition, subtraction, multiplication, or applying built-in functions or operators specific to the data types. 8. Using control structures. Conditional branching allows the program to make decisions based on certain conditions using if-then else statements. Loops enable repetitive execution of a block of code, such as while loops, for loops, or repeat loops. 9. Manipulating data in a list. Declaring a one-dimensional array involves specifying the data type and the size of the array, example, int, numbers equals new int, 10. Reading from and writing to arrays involves accessing elements by their index, example, numbers, 0, equals 5, int value equals numbers, 2. Traversing arrays means iterating over each element in the array to perform some operation on them, example, using a for loop. Linear search is a technique to find the position of an element within an array by iterating over the array and comparing each element until a match is found. 10. Performing checks and tests on programs to verify correctness. Testing involves executing the program with various inputs to verify its behavior and check for errors or bugs. Debugging is the process of identifying and fixing errors or issues in the program. Techniques for testing and debugging include using test data, stepping through code, adding print statements, or using debugging tools. 11. Writing documented programs. Documentation is important for understanding and maintaining programs. Internal documentation includes using meaningful variable names, adding comments to explain code logic, indentation for readability, and effective use of white spaces. External documentation includes user manuals or guides that explain how to use and interact with the program, providing instructions and explanations. Applications and implications of information and communications. 1. Data communications and networks. Data communication, the process of transmitting data or information from one location to another through the use of electronic or optical signals. Network, a collection of interconnected devices, computers, servers, routers, etc., that can communicate and share resources with each other. 2. Types of networks. Local area network, LAN, a network that covers a small geographical area, such as a home, office, or campus. Wide area network, a network that spans a large geographical area, often connecting multiple LANs together, such as the Internet. Metropolitan Area Network, MAN, a network that covers a larger area than a LAN but smaller than a WAN, typically covering a city or metropolitan area. 3. Types of transmission media. Cable/wired media. Coaxial cable, a type of cable that consists of a central conductor surrounded by insulation, a metallic shield, and an outer cover. Fiber optic cable, a high-speed transmission medium that uses thin strands of glass or plastic to transmit data as pulses of light. Twisted pair cable, a type of cable that consists of pairs of insulated copper wires twisted together. Wireless media. Satellite, communication through the use of satellites in orbit around the Earth. Microwave, communication using high-frequency radio waves. Infrared, communication using infrared radiation. 4. Wireless network technology. Bluetooth, a wireless technology used for short-range communication between devices. Wi-Fi, a wireless technology that allows devices to connect to a local area network using radio waves. Hotspot, a location where Wi-Fi access is provided to users. Modem, a device that modulates and demodulates signals to transmit data over communication lines. Bandwidth, the capacity of a communication channel to transmit data, often measured in bits per second, bps. Broadband, high-speed transmission that can carry multiple signals simultaneously. Narrowband, low-speed transmission that can carry only a single signal at a time. Voice band, the frequency range used for transmitting voice signals over traditional telephone lines. Communication modes. Simplex, one-way communication, where data flows in only one direction. Duplex, two-way communication, where data can flow in both directions simultaneously. Half-duplex, two-way communication, but data can flow in only one direction at a time. Point-to-point, communication between two specific devices. Broadcast, communication to multiple devices simultaneously. 5. Internet. The Internet is a global network of interconnected computers and networks that use standard protocols to communicate and share information. It provides various services and resources such as email, web browsing, file transfer, and online communication. 6. Measures to secure data and maintain data integrity. Passwords, using strong passwords and enforcing regular password changes. Encryption, converting data into a coded form to prevent unauthorized access. Virus protection, using antivirus software to detect and remove malicious software. Firewall, a network security device that monitors and controls incoming and outgoing network traffic. Physical access restrictions, implementing measures like biometric systems, guards, and locks to restrict physical access to sensitive areas. Archiving, storing data in a secure and organized manner for long-term preservation. Backup and recovery procedures, regularly backing up data and having processes in place to restore it in case of data loss or corruption. Proprietary data and software, implementing access controls and legal measures to protect proprietary information and software. 7. Current and emerging technological trends. Artificial intelligence, AI, the development of computer systems that can perform tasks that typically require human intelligence. Internet of Things, IoT, the network of physical devices embedded with sensors, software, and connectivity to exchange data and automate tasks. Cloud computing, the delivery of computing resources over the Internet, allowing users to access storage, processing power, and software on demand. Blockchain, a decentralized and secure method of recording and verifying transactions. Virtual reality, VR, and augmented reality, AR technologies that create immersive virtual experiences or overlay digital information onto the real world. 8. Impact of information technology on job skills and careers. Information technology has significantly impacted job skills and careers by creating new job roles and career paths related to IT, increasing the demand for individuals with technical skills and expertise, changing the nature of work and requiring adaptability to new technologies, automating certain tasks, leading to job displacement in some areas, facilitating remote work and telecommuting opportunities. 9. Roles of various personnel in computer-related professions. Programmers develop and write code for software applications and systems. Systems analysts and designers analyze business requirements and design IT systems. IT managers oversee and manage IT operations, resources, and projects. Systems programmers develop and maintain system software and operating systems. Database administrators design, implement, and manage databases. Network administrators manage and maintain computer networks and systems. File librarians organize and manage digital files and data. Computer technicians provide technical support and troubleshooting for hardware and software issues. Computer engineers design and develop computer hardware components. Software engineers develop and maintain software applications and systems. Software testers verify and validate software functionality and quality. Webmasters manage and maintain websites. Web developers design and develop websites and web applications. Software trainers provide training and support for software applications. Multimedia artists create visual and audio content for various digital media. Information processing. 1. Distinguishing between data and information. Data refers to raw, unprocessed facts, figures, or symbols. It consists of individual pieces of information without any context or meaning. Information, on the other hand, is the result of processing and organizing data into a meaningful and useful form. It provides knowledge, understanding, or insights that can be used for decision-making or other purposes. In summary, data is the raw material, while information is the processed and organized data that carries meaning and significance. 2. Characteristics and functions of information processing. Information processing involves a series of operations performed on data to transform it into meaningful information. The characteristics of information processing include: input, data is entered into the system for processing. Processing, data is manipulated, analyzed, and organized to derive meaningful information. Storage, the processed information is stored for future retrieval and reference. Output, the resulting information is presented in a useful format for users. Feedback, users can provide feedback or additional input based on the output received. The functions of information processing include data collection, data organization, data analysis, data storage, data retrieval, and data presentation. It aims to convert raw data into meaningful and valuable information that can support decision-making, problem-solving, communication, and other activities. 3. Sources of data in specified application areas. The sources of data can vary depending on the application area. Some common sources of data include internal databases, data collected and generated within an organization through various processes, such as sales transactions, customer records, employee information, etc. External sources, data obtained from external entities, such as government agencies, industry reports, market research, public surveys, etc. Sensors and devices, data collected from sensors, Internet of Things, IoT, devices, monitoring systems, and other sources of real-time or automated data. Social media and web data, data extracted from social media platforms, websites, online forums, blogs, etc. Surveys and questionnaires, data collected through surveys or questionnaires administered to individuals or groups. Research studies, data gathered through scientific research studies, experiments, observations, etc. 4. Methods of validation and verification of data. Validation and verification are important processes to ensure the accuracy, reliability, and integrity of data. The methods used for validation and verification include range checks, comparing data values against predefined minimum and maximum limits. Reasonableness checks, evaluating data for logical consistency and coherence. Data type checks, verifying that data is of the expected type, example, numeric, alphabetic, date. Inconsistency checks, identifying and resolving discrepancies or contradictions within the data. Double entry, entering data twice and comparing the two entries to identify and correct typographical or transposition errors. Cross-referencing, comparing data against external sources or known references to ensure accuracy. 5. Appropriate verification and validation checks given a particular scenario. The choice of verification and validation checks depends on the specific scenario and the type of data being processed. For example, in financial applications, range checks can be used to validate monetary values, reasonableness checks can ensure that debit and credit entries balance, and double entry verification can catch any errors in financial transactions. In data entry forms, data type checks can be performed to ensure that the correct type of data is entered in each field. In scientific experiments, cross-referencing data against known standards or performing consistency checks can help ensure accurate results. In inventory management, cross-referencing physical counts with recorded data can identify discrepancies or inconsistencies. The appropriate verification and validation checks should be selected based on the specific requirements and characteristics of the data and the application being used. 6. Methods of file organization and access. File organization refers to the structure and arrangement of data within a file, while file access refers to how data is retrieved or manipulated within a file. Some common methods of file organization and access include sequential organization. Data is stored in sequential order, and access is performed sequentially from the beginning to the end of the file. Random organization. Data is stored in no particular order, and access can be done directly using a key or identifier. Index sequential organization. Data is organized sequentially, and an index is created to facilitate direct access to specific records within the file. Direct access organization. Data is stored in fixed-sized blocks or records, and direct access to any record is possible using its physical address or calculated location. Sequential access method. Data is accessed one record after another in a sequential manner. Direct access method. Data can be accessed directly without the need to traverse through preceding records. 7. Selecting appropriate file organization for a particular application. The choice of file organization depends on the specific requirements and characteristics of the application. For example, sequential organization with sequential access is suitable for applications that require processing data in the order it was entered or maintaining a chronological order, such as log files or transaction records. Random organization with direct access is appropriate when quick retrieval of individual records based on a specific key is necessary, such as a customer database where records can be accessed directly by customer ID. Index sequential organization combines the benefits of sequential organization for efficient storage and direct access through an index for quick retrieval of specific records. It can be useful for large files where both sequential and direct access are required, such as in a library catalog system. The appropriate file organization should be selected based on factors such as data access patterns, storage efficiency, retrieval speed, data integrity requirements, and the nature of the application. 1. The purpose of a spreadsheet is to organize, analyze, and manipulate data in a structured format. It allows users to create tables with rows and columns, enter data into cells, perform calculations and formulas, and generate charts and graphs for data visualization. 2. Terminology and notions commonly associated with spreadsheets include row, a horizontal line in a spreadsheet that contains cells. Column, a vertical line in a spreadsheet that contains cells. Cell, a single unit in a spreadsheet where data can be entered. Cell address, a unique identifier for each cell, typically represented by a combination of the column letter and row number. Label, text entered into a cell to describe or identify data. Value, numerical or text data entered into a cell. Formula, an equation or expression used to perform calculations in a spreadsheet. Function, a predefined operation or formula that can be applied to cells or ranges of cells. Worksheet, a single sheet within a spreadsheet file where data is organized and manipulated. Template, a predefined format or layout that can be used as a starting point for creating a new spreadsheet. Range, a group of cells that are selected together, often used in formulas and functions. Title, a descriptive heading given to a row or column. Window, the visible area of a spreadsheet on a computer screen. Record, a complete set of data that corresponds to a single entity or item. 3. Basic predefined system functions commonly used in spreadsheets include sum, calculates the sum of a range of cells. Average, calculates the average value of a range of cells. Date, inserts the current date into a cell. Max, finds the maximum value in a range of cells. Min, finds the minimum value in a range of cells. Count, counts the number of cells that contain numerical values within a range. If, evaluates a logical condition and returns different values based on the result. VLOOKUP, searches for a value in the leftmost column of a table and returns a value from a specified column. Rank, determines the rank of a value in a list. 4. Advanced arithmetic formulas in spreadsheets can include addition, plus adds two or more numbers. Subtraction, subtracts one number from another. Multiplication, asterisk multiplies two or more numbers. Division, / divides one number by another. Exponentiation, caret raises a number to a power. Square roots, calculates the square root of a number. Use of brackets, controls the order of operations in complex formulas. 5. Common features of spreadsheet software include formatting, allows users to customize the appearance of cells, such as font style, size, and color. Sorting, arranges data in ascending or descending order based on selected columns. Filtering, displays only specific rows of data based on specified criteria. Charts and graphs, enables the creation of visual representations of data for better analysis and presentation. Conditional formatting applies formatting rules to cells based on certain conditions. Data validation defines rules and restrictions for the type and range of data that can be entered into cells. Importing and exporting allows users to bring in data from external sources or export spreadsheet data to other file formats. Collaboration supports simultaneous editing and sharing of spreadsheets with multiple users. 6. Row and column title locking, also known as freezing or freezing panes, allows users to keep certain rows or columns visible while scrolling through a large spreadsheet. This feature is useful when working with large datasets, as it ensures that important labels or headings remain visible as you navigate the data. 7. To replicate or copy formulas into other cells, you can use the fill handle. The fill handle is a small square located in the bottom right corner of a selected cell. By dragging the fill handle across adjacent cells, the formula will be automatically adjusted to reference the appropriate cells based on the relative position. 8. Manipulating data on a spreadsheet involves tasks such as entering data into cells, editing existing data, deleting data, and performing calculations using formulas and functions. Spreadsheet software provides various tools and commands to manipulate data efficiently. 9. Manipulating columns and rows involves tasks such as inserting new columns or rows, deleting existing ones, resizing column widths or row heights, and adjusting the order of columns or rows. These operations help in organizing and structuring data within the spreadsheet. 10. Formatting a spreadsheet includes customizing the appearance of cells and the overall layout. It involves applying formatting styles, changing font attributes, adjusting cell borders, setting number formats, aligning data within cells, and applying conditional formatting to highlight specific values or conditions. 11. Sorting a spreadsheet involves arranging the data in ascending or descending order based on the values in one or more columns. It helps in organizing and analyzing data systematically, making it easier to identify patterns and trends. 12. To find a record matching a given criterion, spreadsheet software provides a find command. This command allows users to search for specific values or patterns within the spreadsheet and quickly locate the corresponding cells or records that meet the given criteria. 13. Spreadsheet software provides charting operations to create visual representations of data. Users can select data ranges, choose appropriate chart types, example, bar charts, line graphs, pie charts, customize chart elements, and generate graphical representations of the data for better analysis and presentation. 14. The selection of an appropriate graphical representation of data depends on the type of data being visualized and the purpose of the presentation. Bar charts are useful for comparing categorical data, line graphs show trends over time, and pie charts display the composition of parts within a whole, among other types of charts. 15. Spreadsheet software allows users to work with multiple worksheets within a single file. This feature enables organizing related data or different aspects of a project into separate sheets. Users can navigate between worksheets, copy or link data between them, and perform calculations and analysis across multiple sheets. 16. Importing files into a spreadsheet involves bringing data from external sources into the spreadsheet software. This can include importing data from text files, CSV files, databases, or other spreadsheet files. Importing allows users to work with data from different sources within a unified spreadsheet environment, facilitating analysis and manipulation. Database management. 1. Explanation of a database. A database is a structured collection of data that is organized and stored in a computer system. It serves as a repository or container for storing and managing large amounts of related information. Databases are designed to facilitate efficient data storage, retrieval, manipulation, and analysis. They provide a structured and consistent way to store data, ensuring data integrity and reducing redundancy. 2. Terminology commonly associated with a database. Table, relation. A table is a fundamental component of a database. It represents a collection of related data organized in rows and columns. Each row in a table is called a tuple or record, and each column represents a specific attribute or field of the data. Entity. An entity refers to a distinct object or concept in the real world that is represented in a database. It could be a person, place, thing, event, or any other item of interest. Attribute. An attribute is a characteristic or property of an entity that is stored in a database. It corresponds to a column in a table and defines the type of data that can be stored, such as alphanumeric, numeric, date, or logical data. Primary key. A primary key is a unique identifier for each record in a table. It ensures that each record is uniquely identifiable and helps establish relationships between tables. Secondary key. A secondary key is a field or combination of fields that is not the primary key but still has a unique value for each record. It can be used for searching and sorting data efficiently. Composite key. A composite key is a primary key that consists of multiple columns or fields. It is used when a single field is not sufficient to uniquely identify a record. Candidate key. A candidate key is a potential primary key that meets the requirements of uniqueness and non-nullability for a table. Alternate key. An alternate key is a candidate key that is not selected as the primary key. Foreign key. A foreign key is a field or set of fields in one table that refers to the primary key in another table. It establishes relationships between tables and ensures referential integrity. 3. Distinguishing terminology associated with files and databases. Files and databases serve different purposes and have distinct characteristics. Here are some differences in terminology. Files. In a file-based system, data is stored in individual files that are often unstructured. The equivalent of a table in a database is a file in a file-based system. Records. In files, data is organized into records, which are similar to tuples or rows in a database table. Fields. Fields in files are equivalent to attributes or columns in a database table. Keys. While files may have keys, they are typically not as strictly defined as in databases. Database keys, primary, secondary, foreign, provide more robust mechanisms for data integrity and relationships. Relationships. Files generally do not have built-in mechanisms for establishing relationships between different files, whereas databases can establish relationships using foreign keys. 4. Advantages of databases. Data integrity. Databases enforce data integrity rules, such as primary key constraints and referential integrity, to maintain the accuracy and consistency of data. Data consistency. With databases, data is stored in a centralized manner, ensuring that updates and changes are reflected consistently across all related tables. Efficient data retrieval. Databases use indexing and optimized algorithms for efficient data retrieval, allowing fast access to specific records based on search criteria. Data security. Databases provide features like access control, user authentication, and encryption to protect sensitive data from unauthorized access. Data sharing. Databases enable concurrent access to data by multiple users or applications, facilitating collaboration and data sharing. Data scalability. Databases can handle large volumes of data and can be scaled up or down to accommodate changing data requirements. Data backup and recovery. Databases offer mechanisms for regular backups and recovery to protect against data loss or system failures. Data independence. Databases separate the logical representation of data from its physical storage, allowing applications to access and manipulate data without worrying about underlying storage details. 5. Creating a database. To create a database, you typically use a database management system, DBMS, software such as MySQL, Oracle, Microsoft SQL Server, or PostgreSQL. The exact steps may vary depending on the specific DBMS, but the general process involves the following. 1. Install and set up the DBMS software on your computer or server. 2. Launch the DBMS software and connect to the server. 3. Use the DBMS interface or a specific programming language, example, SQL, to create a new database. 4. Specify the database name, file locations, and other configuration options as needed. 5. Create tables within the database by defining their structure, including column names, data types, and constraints. 6. Define relationships between tables using primary and foreign keys. 7. Optionally, populate the tables with data using insert statements or import data from external sources. 6. Modifying a table structure. To modify the structure of a table in a database, you can perform actions such as adding new fields, deleting fields, or changing field definitions. The exact syntax and options may vary depending on the DBMS you are using. Here are some common actions. Adding a new field, you can use the alter table statement to add a new column to an existing table. Specify the table name, the new column name, and its data type. Example, alter table name add column name data type. Deleting a field, use the alter table statement with the drop column clause to remove a column from a table. Specify the table name and the column name to be deleted. Example, alter table name drop column name. Changing field definition. The alter table statement can also be used to modify the definition of an existing column, such as changing its data type or size. Example, alter table name modify column name new data type. Remember to take precautions and ensure data consistency when modifying table structures, as it may impact existing data and applications relying on the database. 7. Sorting a database. To sort a database, you typically perform a query that includes an order by clause. The order by clause allows you to specify the columns to sort by and the sort order, ascending or descending. Here's an example. Select asterisk from table name order by column name ASC/desk. Select asterisk, retrieve all columns. From table name, specify the table from which to retrieve data. Order by column name, specify the column to sort by. ASC/desk, specify the sort order as ascending, ASC, or descending, desk. You can sort the data based on multiple columns by listing them comma-separated within the order by clause. For example, order by column 1 ASC, column 2 desk. 8. Establishing relationships. In a database, relationships between tables are established using keys. Here are the key types commonly used to establish relationships. Primary key, PK. The primary key uniquely identifies each record in a table. It is used as a reference in establishing relationships with other tables. Typically, the primary key is an auto-increment or manually assigned value. Foreign key, FK. A foreign key is a column or set of columns in one table that refers to the primary key in another table. It creates a relationship between the two tables. The foreign key ensures referential integrity, maintaining consistency, and preventing orphaned records. To establish a relationship between tables. 1. Identify the primary key column in the parent table, reference table. 2. Add a foreign key column in the child table, referring table, that corresponds to the primary key in the parent table. 3. Define the foreign key constraint, specifying the relationship between the two tables. This ensures that only valid values exist in the foreign key column. By establishing relationships, you can perform queries and joins across tables to retrieve related data and maintain data integrity. 9. Querying a database using multiple search conditions. To query a database using multiple search conditions, you can use logical operators such as AND, OR, and NOT. These operators allow you to combine multiple conditions to retrieve specific data. Here's an example. Select asterisk from table_name where condition 1 and condition 2. Select asterisk, retrieve all columns. From table_name, specify the table from which to retrieve data. Where, specify the conditions for filtering data. Condition 1, condition 2, replace these with the specific search conditions based on the column values you want to match. You can use parentheses to group conditions and control the order of evaluation. Example, where, condition 1 and condition 2, or condition 3. You can also use other comparison operators like equal sign, less than sign, greater than sign, less than or equal to sign, greater than or equal to sign, etc., to define the conditions based on the data you are searching for. 10. Determining the results of a search on a database given multiple conditions. When you perform a search on a database with multiple conditions, the result will include only the records that satisfy all the specified conditions, logical AND. In other words, the results set will contain the records that match all the given search criteria simultaneously. For example, if you have a table of employees and you want to find employees who are in the sales department and have a salary greater than $50,000, the result would include only those employees who meet both conditions. The use of logical operators like AND, OR, and NOT allows you to combine conditions and control the outcome of the search query. By specifying multiple conditions, you can narrow down the result set to the specific records that meet all the given criteria. 11. Generating reports to the screen, printer, and files. Most database management systems provide features for generating reports. These reports can be displayed on the screen, sent to a printer for physical output, or saved as files in various formats. To generate reports, you typically use reporting tools or query languages like SQL to extract data from the database and format it according to specific requirements. Some common features and techniques for report generation include sorting the data based on specific columns to present it in a desired order. Grouping data based on certain criteria to create summary sections or subtotals. Statistical and summary features, calculating statistics such as count, sum, average, minimum, maximum, etc., for specific fields or groups. Formatting, applying formatting options like headers, footers, page numbering, fonts, colors, etc., to enhance the visual appearance of the report. Output options, choosing whether to display the report on the screen, send it to a printer, or save it as a file in formats like PDF, CSV, Excel, etc. The exact methods and tools for generating reports depend on the database management system and reporting capabilities provided by the specific software you are using.